This is our introduction into financial mathematics, starting with savings. The first few series of questions we'll go through, look at simple interest, which is you just get your interest and you take that interest. And then the next series we'll look at compound interest. So for this particular type of question with simple interest, we're dealing with a formula where A is the accumulated value. So this is the value we will have at some time in the future. We take the principal value, what we deposit, our savings, we multiply it by 1 plus the rate times the time. Okay, so that's in the textbook. It explains all the details about it. But in this series of videos, we are going to look at how to apply it. Okay, so let's start off here with question 1. We've got Janelle investing $18,000 at 8% simple interest for 41 years. The question is how much will be in the account at the end? So what's the accumulated value? So we're looking for the accumulated value. We put a principal or a deposit of $18,000, so that goes there. We have 1, which is the 100% she will get back. She'll get back all her money, plus this term here will be the interest, which is 8%. We want to write it as a decimal, so 8% is 0.08 times the number of years, 41. Okay, so when we'll go through this one step by step. 0.08 times 41 ends up being 3.28. We still have the 1 plus. We have our 18,000. 1 plus 3.28 is 4.28. And then when we multiply that by 18,000, we will get our accumulated value is $77,040. Okay. Depending upon your calculator, you may be able to enter this all on one line and it will calculate it in one step. For the future questions, that's what we're going to kind of assume. But if you have a very basic calculator, you may need to go step by step and use order of operations. Multiplication inside the parentheses first, multiplication first, then addition, and then finally outside the parentheses the multiplication. Okay, so let's go ahead and set up question number 2. We have Carlos who's investing $15,000 at 2% simple interest for 29 years. So we want to again know the value at the end of the time period, the accumulated value. So we take our 15,000 and multiply it by 1 plus 0.02, that's 2% as a decimal, times 29 years. When we multiply all of this out, we get that our accumulated value is 23,700. Okay, 3, we have Christina. She's going to invest 13,000. And again, we look ahead, they want the accumulated value. So we put in 13,000. She gets all her money back plus 7% simple interest for 32 years. Multiply it all out and we get that the accumulated value is 42,120. These are dollars, so it's always good to have units on numbers when you can. In the calculator, we can't put the units, but at the end for our answers, units are significant. Okay, so this was looking for the accumulated value given a principal and interest. What we're now going to do is take the same formula, but we're going to be asked to find out, we have a savings goal and we want to know how much we would need to deposit. So that's going to be questions 4 and 5 are going to be of that bent. So 4, how much do we need to deposit in order to have 30,000 or 3,000? 3,000 is our accumulated value. We want to know what do we put here so that in the end we have 3,000? So we'll go with 3,000 here. We don't know what our deposit is. That's the question. But what we do know is we always have this 1. It's part of the formula. That's the 100% we're going to get back. And then we do know our rate, 0.02. And we know our time. We're going to do it in 5 years. So we have a 5-year goal of, we need this $3,000. What do we put away now so that we have it in the future? So then we take this one sort of step by step. Nothing we can do with the 3,000. We're going to simplify within the parentheses. So we're taking 0.02 times 5 and then adding it to 1, and that gives us 1.9. Now this is where we get to the point where we need to do some algebra. If we knew what we needed to deposit, we would multiply by 1.9, but since we don't know, we're going to do the inverse operation, which is division. Okay, so you'll see this consistently. Since we can't multiply because we don't know what the variable is, we don't know what that letter is, we're going to divide by 1.9. So we get our final answer that our principal is going to be 3,000 divided by 1.9. So when you do that, you get that we will need $2,727.27. Interesting pattern, 27, 27, 27. So we need to deposit that much money, and in 5 years it'll become 3,000. The interest at simple interest. Okay, let's take a look at 5. For 5, we have a savings goal of 2,000 in 15 years. So the goal is 2,000. We don't know what we need to deposit. That's what we're looking for. We've got our 1, and we get 6% on this one. And we're going to have it deposited for 15 years. I just realized I copied something, so instead of making the whole video, maybe you realize this. This wasn't 1.9. Got ahead of myself. It was 1.1. 1.1. Okay, good. Because this one is going to give us 1.9. So we get 2,000 equals P 1.9. There we are. And again, since we can't multiply, the opposite of multiplication, the inverse is division. So we take our 200 divided by 1.9. Now in algebra class you may have learned divide both sides by 1.9. And that's true. This cancels out. That's why it's going away. I'm just sort of simplifying. Just say, instead of multiply, let's just divide the other side. And that will give us our answer. 2,000 divided by 1.9 is $1,052.63. So that's what we needed to deposit. And then we will have our 2,000 in 15 years.